Hello everyone, hope you guys are doing fine today. It's about 9:01 a.m. Tuesday morning, September 13th, 2022, here in Japan. I have a very interesting video today. This past weekend, as you know, September was September 11th. An event happened this weekend and we concluded that this definitely kills the heliocentric model. And I'm gonna be explaining here today exactly what we know. So last Sunday we went live from Japan and Brazil simultaneously for an event that happens quite often actually. Let me explain to you. Here we have the world according to the Mercator projection, and you see the red line there. That's the equator line. Now when we go to timeanddates.com and then you have that date, September 11th, around 7 p.m. Okay, I took the screenshot 6:30 just before we started our show, but the event really started at 7 p.m. here in Japan. That's when the moon was visible in the skies of Japan and in Brazil at the same time. Now, you don't need to pay attention on the guy in the US because he joined the conversation. He showed the moon just south of Los Angeles towards the southwest. But the important part that you need to pay attention today is that we were able to see the full moon here in Japan and in Brazil at the same time. Here I have converted that screenshot from timeanddate.com into a projection, a flat earth map. Right, that you see that the moon and the sun are exactly on the opposite side. And they were at the opposite side right at the equator. Now, you know what that means. It means that in between that red line, which is the equator, that's the whole world, according to the heliocentric model. So both the moon and the sun, they were 180 degrees facing each other. And in between that 180 degrees, you need to understand that the whole world needs to fit there, right? Because according to the heliocentric model, the sun and the moon, the earth spins, and at the some time in the year, earth lines up in between both of them. So that's what you see in this image. And at the same time, we were able to see the moon, the full moon, in Brazil and Japan at the same time. And I'm gonna be showing you the video, the live footage when we did this. So just remember that in between that red line, which is the equator line, the whole world should fit in there according to the heliocentric model. So let's move to the heliocentric model and then I will explain better what I mean. So there you have it. You have the full moon right at the equator, and you have also the sun right at the equator facing Africa. And in between, you have Earth. So remember, you have 180 degrees where the sun is, according to the heliocentric model and timedate.com. The moon is at that day. On the other side, on the Pacific, right at the equator. And then looking from the other side, imagine that you're in space, you go to the other side and you see Japan also. We were facing a full moon at 7 p.m., September 11th. And on the other side, right above Africa, on the equator, the sun, that's the position of the sun, right? And remember, between the moon on the Pacific side and Africa, it's 180 degrees difference on the globe model. Here you have a view from the top. Okay, just imagine that you can see the whole thing from the top. You see the North Pole right there. Japan on one side, exactly 180 degrees. You have Brazil on the other side. And then you have a lit moon, a full moon on 90 degrees west right at the equator from Brazil, looking from Brazil, 90 degrees east from someone who is in Japan, looking at the full moon. In between the full moon and the sun, you have Earth. Here you have the coordinates here in Japan, where we were, 36 degrees latitude north, 138 longitude east, and that was 7 p.m. here in Japan, 7 a.m. in Brazil, 12 hours, exactly 180 degrees on the other side of the state of Rio Grande do Sul in Brazil, where Clayton recorded the moon, which I'm going to show you here. It's exactly 180 degrees. So here you have all three put together. On the top left, you see the view as seen from Japan. Outside in space, you see sun. In between the sun and a full moon, you have Earth. On the top right, you see the same situation. The moon, full moon, the sun, right at the equator, in between Earth and somebody in Brazil, being able to see both at the same time, the full moon and the sun. And on the bottom, you see a view from the top of North Pole. You see Japan and Brazil standing 180 degrees on the ball Earth, in between the sun and the full moon. This is impossible on the heliocentric model. Why wasn't there a lunar eclipse on that day? So according to NASA, what's a lunar eclipse? So right there, a total lunar eclipse occurs when the moon and sun are on opposite sides of Earth. Exactly what happened on September 11th, 2022. At least we should have a partial lunar eclipse, which according to NASA happens when only part of Earth's shadow covers the moon. But we had neither. We had a full moon. This is ESA, the European Space Agency definition. A lunar eclipse happens when Earth passes between the sun and the moon. Here you have another explanation for kids.
Since the moon continually revolves around the Earth, it's only natural that it sometimes comes between the sun and the Earth, while at other times it goes behind the Earth, so that the Earth comes between the moon and the sun. When the latter happens, we see a lunar eclipse.
So where is the lunar eclipse? Here on Sunday, September 11th, 2022, 7 p.m. Japan time, 7 a.m. Brazil time. We have a full moon right at the equator and the sun facing Africa right there where you see the mouse being pointed. In between you have Earth, but you have a full moon. So what happened to why don't we have a lunar eclipse? Didn't we have a lunar eclipse that day? There you see on the other side, from space. Look at Japan. We have a full moon. Sorry, it's upside down there, and the sun facing Africa. Both of them standing right at the equator. In between you have Earth, but we can see a full moon. Now let's start. I'm going to show you the footage that we did live on Sunday. So this is Clayton. He lives in Rio Grande do Sul. It's a state south of Brazil. And I'm gonna post a link if you want to watch the whole video. The problem is the video is mixed between Portuguese and Japanese, so you might not be able to understand, but I have added here the parts that matters, okay? So that the name of the video says Lua Cheia Simultânea Brasil e Japão, Full Moon Simultaneously Brazil and Japan, September 11th, 2022. So let's go ahead and watch the video. So this is Clayton, he's pointing at the moon, and that he's in Brazil, right there. You can see the full moon when he faces west, and he's going to show the sun to the east. Sorry, the guys are speaking Japanese. in the background, but that's the moon, full moon. Okay, here's now that's the sun right there. And now we're gonna see here in Japan, that's Mauritius channel. Here you had a P1000, Mauritius, Shizuoka, Japan, and 7 p.m., 7:10 after 7. So that's it. You can see Japan and Brazil both can see a full moon, which means Earth, according to the heliocentric model, should be exactly in between both of them.
Lembrando que é o extremo, né? Entre Guaíba e Porto Alegre. Vou fazer um giro aqui, ó.
That's the sun to his east and the full moon to his west. Right? Exactly as you see displayed on the picture above. And that's in Japan. Same time, that's the illustration that shows exactly full moon. That's it, guys. This is the end of the heliocentric model. The guys are celebrating in the back, the back sound. The full moon seen at the same time in Brazil and Japan. Impossible on a heliocentric model. Just impossible. So that's where you gotta understand that Earth, the whole Earth, ball Earth, has to be in between those two right there, the full moon and the sun. All right. So that's what happens there. We should have a full lunar eclipse on that day. So it's clear that what causes eclipses, the lunar eclipse, is not the Earth being in between both of them. I'm gonna leave here 2 links on lunar eclipse. I'll ask you to go ahead and watch this one from this channel. Just ignore the disclaimer by Wikipedia, and the second one, which is one of Eric Dubé's video called How Eclipses Work on Flat Earth. If you're new to Flat Earth, it's really important for you to watch these two. But this is it. There is no heliocentric model. If you just look at the Flat Earth map, you can see and explain better how this event was able to happen on September 11th, around 7 p.m. Japan time, 7 a.m. Brazil. Both countries are 180 degrees opposite on the globe model. But you can see there the moon was over the Pacific Ocean, just at the equator, while the sun was over Africa, right at the equator at the same time. In between, according to the heliocentric model, we should have the whole Earth in between both of them, but this is better explained on the Flat Earth map. So this is it for the globe, guys. It's dead. The globe is dead. There's no heliocentric model. One conclusion that we can get from today's video is that, number one, lunar eclipses are not caused by Earth being between the sun and the moon. That there are dark bodies in the sky that covers the sun and the moon at certain times of the year. And number two, the heliocentric model is a fail model that fails all the tests. It should be discarded. Earth is flat, guys. Thanks for watching. I hope you guys have enjoyed this video. And the sun, the full moon being seen from Japan and Brazil at the same time definitely kills the heliocentric model. Thanks, guys. See you the next time. Bye bye.